All right, today we're talking about negative exponents, and some of you actually brought this up yesterday because you're starting to get me a scenario. Mr. A, what if you have a number to an exponent that is small, that is a smaller exponent than one below? Wouldn't you get a negative exponent? And the answer is yes, you would. So let's look at one here where that scenario would work out. So x to the third divided by x to the sixth. And we're going to use the quotient of powers. You guys remember that little rule? I'm going to review it because I need you to get this. Ready? Are we dividing powers?
Yes.
Yes. Do they have the same base?
Yes.
What do you do with those exponents? Okay, so I should get a problem that looks like this, or at least I'm thinking through in my head like this. X to the 3 minus 6, right? Because 3 minus 6. So what is 3 minus 6? So I get x to the negative 3. You guys agree with that?
Yes.
Okay, and that's okay. In fact, we use negative exponents a lot, especially in science and math, obviously, because we use, have you guys heard of scientific notation?
Yes.
Do you guys remember? Okay, scientific notation, and we'll look at an example. Do you guys know DNA?
Yes.
Okay, how big or how long is a strand of DNA for a person? Go ahead, Jack.
It says 10 to the negative 7 meters. So, okay, a meter we said was like that, and we're going to cut that down by 1,000,000. We're going to cut that into 1,000,000 slices there. Or no, 10 million. Wow, 10 million slices right there. Chop, 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 chop. Really fine knife. One of those little parts, you're magnifying that. That contains all the information that your body needs to function. And that information was given to you at birth, which is awesome because I think of my son, Titus, more recently was born. And he started off as 2 cells coming into one, forming one cell. And that cell had all the information that you needed for his hair color, his height, his organs, how they function, how they develop, all that kind of stuff in one cell. And you know how long that strand was? Let me show it to you. Ready? Can you see it? No. And I'm actually making it huge. It's actually much smaller than that. Actually, squeeze it, and it's right in there. That is amazing because that information is in such a tiny little part of our body. In fact, every little cell in your body, every cell, so every cell in your skin, on your organs, anywhere, contain all the info for your body, all of it. It can tell me everything about you, and we use that info nowadays for a lot of different cool things, I think. But anyway, you use negative exponents because you cannot describe that. You're not going to say, that's a meter long. No, it's way too small. That's way too big. It's not even a centimeter, not even a millimeter. It's very, very small. Okay, let's look at this another way, though. I'm going to do the same problem, but I'm going to look at it a different way. Kind of like the old school way, the long way, where I write out all the factors. So do you guys remember how to write x to the third with prime factorization? Do you remember how to do that, Callie? So you write this as multiplication. Okay, and then how do you write x to the sixth as a multiplication problem?
6x.
1, 2, 3, 4, 5, 6. Okay, and I just want to make sure I got it checked out here. Okay, and do you guys remember you can cross out a certain amount of x's because they're both in the numerator and denominator? So how many can I cross out? Marissa? 3 of them. All right, I'm going to cross out these 3 and these 3, and that gives me 1 over 1. Correct? So we're just doing this problem like we normally did. Now, let's see what we're left with. What's 1 times, well, there's nothing else there. So what's 1?
1.
This is 1. All right. So get 1 is left up there. What's 1 times x times x times x? X to the?
How did you get 1 for the bottom?
For the top? Or what? So these 3 x's cancel out those 3 x's, made it 1 over 1. Or x to the third over x to the third is 1 over 1, which is kind of what your homework was on some of those. Q to the second over q to the second is 1. Yes, ma'am?
Why, since we're talking about negatives, why wouldn't it be 1 over x to the third, not negative?
Okay, are you guys noticing something here? I hope you are.
Did we work out a different problem or the same problem? Well, we did different ways, right? And we got, wait, these are not the same thing, are they?
The ratio, right?
They are the exact same value. They're the same value. Okay, now watch what I'm going to do here. As my son Ezra says, watch my do. So x to the negative third is equal to 1 over x to the positive third. According to this problem here, and I'll scroll back up. According to this problem right here, it's the same problem, so I can't get different answers, like I can't get different values, but wait, I got them in different ways. These two ways are the same value, okay? And that's what we're talking about with negative exponents. Yes, ma'am.
Is there a way to transfer the fraction into a x negative 3?
Yep. You're going to be, this lesson today is going to be you turning this into this, and you turning this back into that. You're going to go back and forth because they're the same value. And you guys don't look super confused, which is a good thing. But let's look at the negative exponents in algebra, an algebraic form. Okay, so here you need to write negative exponents. And let me just use algebra to describe all the times you're going to use negative exponents. So a to the negative n power, a to the negative nth. Okay, you can say that, or just a to the negative n power. That's fine. Is also equal to 1 over a to the positive n power. Okay, that's a definition. And so far, no one looks mad at me, which is a good sign. And is that kind of hard to swallow right now? I think it is. I don't think it's easy to just say, yeah, I get it. But from our example, that is true. So is this a correct value for my problem here? Yes. Is this a correct value for my problem? It is. And they're both the same.
So all you have to do is put 1 over whatever your answer was and then get the minus sign out of there.
Okay, so that's a way to think of it. Let's look at example 1a, and let's see how we work these problems out. So example 1a. And I'm just getting you trained with understanding how to rewrite it. Just get used to rewriting it, and then understanding it, I will try to do my best, because that is hard. 10 to the negative fifth, that's a. 10 to the negative fifth. All right. I want to rewrite it according to example 1. Write each expression using positive exponents. So let me ask you right now, do I have a positive exponent? No. So I need to write it with a positive exponent. So according to this definition, how would I write 10 to the negative fifth with a positive exponent? Jack? 1 over 10 to the fifth. That's correct. That's it. Man, I love this stuff. Oh, this is cool. We're getting there. Oh my. Brace yourself for these next ones. Okay, B. B is a little bit tougher, but I hope you guys can get it. It's AB to the negative third. Okay, now I'm going to ask you a question. You have to answer wisely. So don't just give me an answer because it might not be the right answer. Is this expression written with only positive exponents? No. All right, but doesn't A have a positive 1? Okay, so I can write that in, or I could just think of it. So I'm good with the A, but the B has a negative exponent. So how can I change B to have a positive exponent instead of that negative 3? Go ahead, Bree. What do you think?
You can do what we've been doing, so 1 over b to the third.
And then what happens to that A?
You put it in front of it.
Okay, ready, guys? What's going on between these two values?
They're being multiplied.
Okay, so I'm going to write that in like some of you kind of like doing anyway. So I'm just changing it so I can see it better. Do I need to change anything with A? No, he has a positive 1. He's good. But I need to change this B to the negative third. So A gets the same. How would I change B to the negative third, Braden? You said it already. 1 over b to the third, or 1 over b cubed, right? You guys see that? And then how do I finally combine these back together? It's like you separate them, change one of them, and bring it back together. So how would I bring these back together? Because That is not simplified form. Yes, ma'am? It would seem like that, right? But isn't this a technically in its numerator, and that's in its denominator? So I'm like, how do I merge that together properly?
You replace the 1 with the A.
Okay, this is going to become a over b cubed. A over b cubed, that's your final value. And if you guys are not getting that, do you guys remember how to multiply fractions? Okay, isn't this a fraction? Isn't it a over 1? So it's a times 1. A times 1 is a. What's 1 times b cubed?
B cubed.
So do you see how I can get it that way as well? So we're not doing anything improper or even complex. We're just kind of multiplying across. Okay, let's look at page 212. Let's just get some more practice here. And I'm gonna call on people that give me an answer. Okay, so you may have a raised hand, you may not. Let's look at number 4. 3 to the negative third. I want to write it with positive exponents, or a positive exponent. So Michael, how would I rewrite this to make it a positive exponent?
You'd write 3 to the positive third over 1.
Close. Say that again.
3 to the positive third under, no, 1 over.
There you go. And I think that's what you meant, but that's now 1 over 3 to the positive third, right? You guys okay with that? Okay, good job. Number 5. Oh my, 15 to the negative fifth. What? 15 to the negative fifth. How would I write that, Max?
1 over 15 to the fifth.
1 over 15 to the fifth. Wow. Good job, guys. You guys are pretty much nailing this. All right, I want you guys on your own to do number 6. And we'll see what the answer is in just a moment. Number 6. 212. Number 6. That's a variable. You can't mess with that. I know Braden knows. Emma Grace?
1 over 8.
My goodness, guys. Really? That's it? Okay. That's that. We need a second part, though. This first part, we just completed. By the way, guys, you notice on all 3 of these the last 3 problems, 4, 5, and 6, we've been trying to make them into positive exponents. What do you think we're going to do now? Make them into negative exponents since they start off being positive exponents. All right. Oh, no. What are we going to do?
Mind blown.
Okay, let's look at number 7. I'll work that one out with you guys. So it's 1 over 10 to the 7th. 1 over 10 to the 7th. And I'm going to rewrite that, and if you're looking at number 7, it says in the instructions, write each fraction as an expression using negative exponents. So does this have negative exponents? No. I need to write it so that it has negative exponents. John?
10 to the negative 7.
10 to the negative 7. Is that what you guys would have said?
Yep.
Oh my, look at that. And here is the negative exponents in the reverse way. So if you're not like, how do we just get that? It's this. 1 over a to the nth power is equal to a to the negative nth power. Okay? Mr. A, isn't that the same thing as what you said way up here? All I did was what? I just switched the 2 sides together. And that's what I got. That's all you're doing. You're going back and forth. Not quite. It gets tough. It gets tough.
How do you do that?
Okay, good. Number 9. That's a good one. 1 over 9. We're gonna go back to this problem. We're gonna look at it a different way in just a moment. But does this have negative exponents? No.
Yes.
Well, not as it is, right? Not as it is. So how do I make it with negative exponents? You're thinking, I don't know. Timothy?
Would it be 9 to the negative?
Whoa, how'd you get that negative 1 there? There's no exponent here. John?
Because from the identity property, any number times itself is the number. So there's like an invisible one right beside it?
Okay, I see what you're saying. Any number times 1 would be the number itself. And here it's just saying you're using 9 as a factor of 1. So it's just a 9. 9 to the first equals 9. So that's good. And then 9 to the negative 1. Okay. You guys get that? I wish that was it. Because you're doing so well. On these last couple, we've been getting negative exponents, right? We want negative exponents. By the way, in Algebra 2, so for some of you a few years down the road, you're going to deal with very complicated expressions where they have x, y, z, a, b, and c, all to powers, some positive, some negative, some in the numerator, some in the denominator, and they want you to write them all with positive exponents, or all with negative exponents, or all in the numerator, all in the denominator. It gets complicated. But if you guys get this right here, I think you're on a good path. Okay, so I'm getting you ready for Algebra 2, but not quite yet. Okay, let's take an example 3. I think this is going to be the hardest part because you got to think a little bit more, and then I think some of you can think through the last example. So kind of keep this in mind right here. Can you keep number 9 in mind? Okay, that's the correct answer for number 9, but I want to look at example 3 because this can get a bit complicated. Okay, example 3. It says, write each fraction as an expression using negative exponents. Okay, so I get 1/8. 1/8. And I initially think, you know what? That's so easy. You just do 8 to the negative 1. And that would be correct. But there's another way to think of it.
Do we have to do this one?
Yes.
Oh.
If possible, so not always possible, is there another way to rewrite this fraction using prime numbers? So can I make 1/8 look like a different type of fraction, as in different look to it, not a different value? Yes, ma'am?
1/2 to the third.
Okay, Sylvia, that's kind of weird. How did you get 2 to the third?
2.
You can't just do that. Emma Grace? Oh my goodness. Wow, we've done it so many times, I totally forgot. Isn't 8 2 to the third?
Yes.
Okay. So now how can I write this with negative exponents? Anybody know? Yes, Caroline? Okay, now I have a question for the class. Is 8 to the negative 1 equal to 2 to the negative third? And it is, right? Same fraction. One written out with prime factorization. You get different numbers, but they're the same value. So good. You guys get that. Okay, and then B. B is not as complicated, I don't think, and we kind of already did it. X over y to the second. I want to write this fraction with negative exponents. So do we have negative exponents here? No, not yet. So how do we rewrite it with negative exponents? Jensen? Or you have a question? Go ahead.
Whenever you get the exponents right there, couldn't you get not a negative number as the end result? Wouldn't that technically be wrong?
Okay, so here on this last example, these two values are equal. One has positive exponents, one has negative exponents, and same thing here, right? So I've been saying this word, I think I probably said this word now roughly 20 times. Exponent. What's the value of the 8? Is it positive or negative?
Positive.
Okay, but didn't it change to negative? What did change to negative? The exponent. So the value of 8 is still positive here and positive here. It's that exponent that's negative. And same thing there. I don't know if that answered your question, but you're just writing it in a different form. Just get practice writing it in different forms, because sometimes this form's better than that one. Like, when can that ever be? We'll get there. Okay. Sorry, we're on B here. And let's see. I wonder if you guys can do this. I really think you can. Can you break this into a multiplication problem? It's kind of like the one we did up here. So if you're looking at your notes, Where are you? Where are you? You're right here. It's kind of like this one. So you can look at your notes on that problem, but can I write this as a multiplication problem? How? Callie?
Yeah, you can do x times 1 and y to the second.
Oh, yeah, you're right. Okay, let me ask you this. Is x times 1 over y to the second x over y to the second?
Yes.
Okay, so you can break it down into that, and now I can see it clearly. How can I write x with a negative exponent? Oh, and actually, let me make sure I get this. See, and they're not even. I don't like this. But anyway, how do I make y to the second a negative exponent? So how do I get this second part negative exponent? Josie? Y to the negative second. And technically, I can get that x as a negative exponent too. So right now, does x have a negative exponent? No. But can I give it a negative exponent? And how would I rewrite it? Max?
Let's do the negative first. I think.
You're close, but how do I write it?
I don't know.
So it's already x to the positive first. So you're good. You're understanding it. Yes? 1 over x to the negative first, right? Is that what you meant? Like 1 over x to the negative first. Okay, and then how do I combine this one right here? I want to make it finally combine, and this is the tough part. This is the tough part. Stay with me, stay with me. Okay, you're looking at, that's a fraction, that's not, or is it? Okay, so Braden.
You do x times, no, x, y.
It's tough. Multiply the numerators. What's 1 times y to the negative second?
No, it's y negative 2 over x.
Yeah, and the book, that's why I was upset, because the book says x, y to the negative second.
Can you write it like that?
Yeah, I guess you could. Okay, questions. Did you get, how about, and see, this is where I backtrack. Did you get from here to here?
Yes.
Okay. Did you get from here to here? Okay, who can explain what happened from here to here? Jack?
We made the little fraction thing and made it a negative.
We made it from a positive exponent to a negative exponent. So remember how we do that? So that's a great question. Is this equal to that? And the answer is
Yes.
yes. That's the interesting. Do you notice, by the way, guys, what basically just happened? This x was in the numerator. Now where is it? And it changed the exponent sign, right? It went from positive to negative. And then where was the y squared in the original problem? In the denominator. Now it's in the numerator, and now it has a changed exponent sign. That's basically what you're doing. Yes. Michael?
So basically whenever you add a 1 over the top of it, are you just changing the sign of the exponent?
Yes. And that's the key, sign of the exponent. Okay, don't worry too much about these guys. You're not going to get too many of those. But this last problem, I think you guys can do. Example number 4, it's the last page of the lesson. And I want to make sure you guys get this. So it's 4, if it says evaluate 4x to the negative third if x equals 3. So if x equals 3. So what do you think I have to do in this problem? I have to evaluate. So what have you done with these problems? Yes, ma'am?
Like the exponents first.
Okay, so I'm going to do this. Instead of x, what should I put in?
3.
So I'm going to do 4 times, right? These were being multiplied times 3 to the negative third. You guys see what I did? I just put in x and replace it with 3. Okay, so now you're like, what do I do? Well, what is this worth?
1 over 3 to the third.
Very nice. So it's 4 times 1 over 3 to the positive third, right?
Couldn't we just work it out?
You could, but this is my step. This is my step-by-step process. All right, do you guys see how I went from here to here?
Yeah.
Okay. Now, because I don't know what that is off the top of my head, but when I look at it here, now I know. What is 3 to the third? 27. All right, ready? It's 4 times 1 over 27.
Why am I saying that's 4 times?
Yeah, which is at 4 times over 27.
4 times.
4 over 27. Oh, I know. 4 times.
Yeah, exactly. Yeah. What's your answer?
Oh,
Yeah,
so,
Michael.
You do 4 over 1. You change the 4 to 4 over 1, and what?
Okay, you can do this, right? If you want to make it fresh, so you get.
4 over 27.
That's your answer.
Why couldn't we just work it out and then do negative 27 times 4?
Yeah.
Negative 27 times 4 is a negative number.
Like
4 over 27 is still positive.
Wait, so 3 to the negative 3, isn't that?
It's 1 over 27. So do you see this? You got that? Do you see how it can turn into that?
Yes.
That's all right. And do you see how this can turn into that?
Yes.
And then you see how 4 can turn into 4 over 1? And if you multiply across, you should get that. So yeah, I get what you're saying, and that's the tough part. It's not trying to apply. You see how it got harder? Like it went easy, easy. Oh my. It got tougher, but I think you guys can handle it. Let me do a couple more and make sure you guys get this. And then I'll let you off on your homework. Number 10, I think it's right across the page. Evaluate 2 to the x power. Oh no, we've never had that. If x equals 2. So what do I do first before I even start trying to solve things? Oh, equals negative 2. Thank you. Yes. Negative 2. That'll help. So what do you think I have to do first in this problem? Yes?
You multiply 2 times negative 2.
Before you even start multiplying, dividing, all that stuff, what do?
You replace the x.
Replace x with negative 2. Very nice. You just replace it. Just replace it right now. Now that's what you're working with. And do you remember what this is? Like, I can't really deal with that as it is. I want to make them into positive exponents because then I can work with it. So can I make it into a positive exponent? And how, Caroline?
1 over 2.
Okay, that equals 1 over 2 to the second. Oh, nice. What is 2 to the second? 4. So what's my final answer? 1/4 is my answer.
Is that the same as negative 4? Because if you do 2 to the negative 2 without the negative 4.
No, 2 to the negative 2 does not equal negative 4. It equals 1/4. No, because remember, this is saying technically that 2 is used as a factor negative 2 times. We don't even understand. Like, I can't even process that. So if I can make it into a positive exponent, then I'm thinking 1 over 2 to the second. Oh, I know that. And that's the tricky part, that this means that.
Ooh, is it basically dividing by 4?
Okay. To be continued. All right, last one, number 11. 3n to the negative second if n equals 4. All right, my very first step is just to replace what with what? Yes, ma'am? Okay, so all I'm going to do right here, and what's going on between 3 and n to the negative second, by the way? So I'm going to do 3 times 4 to the negative second. I don't know what that is. It's not 4 times negative 2, and I don't know what 4 uses a factor negative 2 times means. So I'm going to take this right here and make it positive exponent. And how would I do that? Josie, this right here.
1 over 4.
And it'd still be multiplied by 3, right? And 3 can be written as 3 over? And what would that be?
3 over 16?
Yeah, 3. What? 3 times 1 is 3. And then what's 1 times 4 to... What's 4 to second?
16.
16. 3/16. Okay. It's tough, guys. It takes time, but you get it. All right, your homework. Yes, Brayden, do you have a question? Or? Okay, your homework is... And I'll help you out, guys. If you need help, I will help you out. I'm right here. 13 to 35 on. And that'll be it for tonight. Pages 2. Remember guys? Oh, nice. Some of you handle it. Some of you, I'll give you till tomorrow to figure it out.
I'm not so quick.
Timothy, you have the ability to get a response from people. That's not always, no, that's not always easy to do.